So in this segment, we are focusing on ions, and we want to look at what is an ion. So that's the first question that you need to remember. Well, when we talk about an ion, we can simply say an ion is an electrically. So we can say it is an electrically, an electrically charged particle. So an electrically charged particle, that is what we simply call as being an ion. So let me just give you a roadmap. So if this is an ion, which is an electrically charged particle, so this particle can either be positive, so it can either be positive, or it could be negative. That's what we mean. Now, of course, when it is positive, we call it in this case as being, a cation, if you want. And if it is negatively charged, we call it as being an anion. That's what we call it. So a cation or a cation is a positively charged particle, while an anion is a negatively charged particle. But the question is that I can just summarize here for you is that when, do we have a cation and when do we have an anion? In most cases, you are going to find that those that we call as being metals are going to be forming up cations. Why? Because they actually, lose electrons. In other words, they give away electron through, loss. I can simply say loss of E dash. When I say E bar, I mean electrons. So because of the loss of electrons, they form up metals, form up cations or cations. And on the other hand, mostly those that we call as being non-metals. Non-metals love to actually, gain, and therefore when they gain electrons, usually when they gain of electrons, they form up what we call as being an ion. So that is what you need to remember. So I want to focus now on these we are calling as being, a cation or cation, as others may call it, and see how they are going to, I'll show you how they are going to be formed. So remember, an ion is simply an electrically charged particle. That particle can either be positive or it could be negative. And when it is positive, we are calling it as being a cation. When it is negative, it is an anion. It has become positive because of loss of electron. It has become negative because it is gaining electrons. Let's start with what we are calling as being, the cations. So remember, like I said, when we talk about a cation or a cation is a positively, so we can simply say it is a positively, charged particle. So a positively charged particle, that is what we simply call as being a cation. Now, what that simply means, for it to become, positively charged, it simply means that, a cation has more protons. It has more protons than electrons. So it has got more protons than electrons. In other words, the number of protons are greater than the number of electrons. So when the number of protons is greater than the number of electrons, then you form up what we call as being, a cation or a cation, as you are going to look at. Let's look at, a few. For example, I can talk about, like I said, usually metals form that. So let me talk about, an element which is a metal we are calling sodium, Na, with proton number 11 in this case. So when I look at, with proton number 11, if you remember, in this case that it has got 23 on top, how many protons are there, how many electrons, and how many neutrons are there? This is in a neutral atom. The number of protons, yes, 11. If you remember, the number of electrons will also be the same. The number of protons will be equal to the number of electrons in a neutral atom. but in this case the number of neutron, it will be 23 minus 11, which is going to give us 12. So when you look at the electronic configuration in a neutral, when we look at the electronic configuration in a neutral atom of sodium, in the first shell 2, in the second I'll put up 8, that's 10. How many are remaining to make 11? 1. So you're going to take it into the third shell. So that is what you remember. Now what is going to happen here is that sodium, if you look at the electronic configuration of sodium in a neutral atom, 2, 8, 1. So now what is going to happen is that the sodium atom, is going to lose a single electron to form a sodium atom. Why? You need to remember, I'm going to talk about that in my later discussion, is that for an atom to be stable, it needs to have 8 electrons in the outermost shell. So usually metals, for them to become stable, they give out electron, and therefore it will give away this 1 electron is going to be lost. In other words, it is going to lose 1 electron. So when it loses 1 electron, the new electronic configuration that you're going to have, let me write in a different marker, is going to be 2,8, if you notice there. So it is going to be 2,8. That is what you're going to have. Now if I look at this one, that's the new electronic configuration. In terms of the number of protons, what is going to happen? The number of protons now in the new atom that I have, the number of protons do not change. They are always found in the nucleus, 11. But the number of electrons, it has lost 1 electron, so it is going to remain with it. Initially, how many electrons were there? 11. But because it has lost 1, meaning minus 1, it will have 10 electrons. You get that? So now, what is the overall charge? Well, for you to know the overall charge, you just need to add the protons and the number of electrons. Remember, protons are positive, that's the number of protons, and electrons are negative. How many do you have there? You have a negative 10. So when you add that, you're going to have a positive 1. And this is what we simply call as being the charge on the sodium atom. So therefore, sodium, Na, is written with a positive on top as a superscript there. So that positive there tells you that it has lost 1 electron. Yeah, we don't write 1 plus, so when we just show plus there, that's okay, that it has lost 1 positive. So that is what you need to remember. Let me show you another one that you can talk about. I hope I'm trying to make sense for you. Let's talk about another element, which is a metal, which we call as being magnesium. So magnesium, capital M and small g, it has got 12 and 24. If you look at the electronic arrangement, it will be 2, 8, 2. That's what we mean. This is in a neutral atom. It has neither lost nor gained. So now, if you look at how many protons are there in a neutral atom, there are 12. How many electrons are there? There are 12. How many neutrons are there? It is 24 minus 12, which will give you a 12. And like I said, the electronic configuration is 2, 8, 2. Now, how many electrons does it need to lose? Remember, it needs to have 8 electrons in the outermost shell. So it is easier to lose these in the 2. It is going to give away the 2. So it is actually going to lose, 2 electrons. And when it loses 2 electrons, it simply means the new electronic configuration will become 2, 8. You have seen it has now 8 electrons. It is actually stable. So now remember what we said. The number of protons don't change. There will still be 12. What is going to be changing is the number of electrons. Because it has lost 2, meaning 12 minus 2, I'm going to remain with 10 electrons. So if you want to know the charge, you don't need to beat about the bush. How many protons? They are positive 12. How many electrons are there? They are negative 10. So what is, in this case, what is 12 minus 10? It is a positive 2. This positive 2 you're seeing is actually the charge. So magnesium can be written as Mg, then you write a 2 and a positive there. This is what we call now as being magnesium ion. So we call it as being magnesium ion. That +2 tells you that it has lost 2 electrons. That is what that is simply telling you. Sorry, like in my previous one there, this here, when you see a charge, either positive or negative, so this is called now as being a sodium what? This is called a sodium ion. So this is an ion because it has lost an electron. And how many electrons? It is equal to the size of the charge that you have there on top. So we can go on and so forth, so that we look at all these. I can actually get to show you. Let me just look at maybe the last one on cations. Let me just look at the last one on cations so that you are able to see. I'll talk about another metal in this case, which is aluminium. So aluminium, Al, it has got proton number 13 and 27 there. So the electronic configuration would be 2 in the first shell, 8, that is 10, then in the third shell I have 3. So let's look at how many protons, electrons and neutrons are in the neutral atom. So this is the neutral, the electronic configuration in the neutral atom of aluminium. Protons, yes, 13. Electrons will be 13. How do I get the number of neutrons? 27 minus 13, which will give you a 14. Now, if you notice there, the electronic configuration in a neutral atom is 2,8,3. So remember, it needs to have 8 electrons in the outermost shell, which we call the octet rule. But of course, there are a few exceptions like hydrogen and helium that can have 2 electrons in the outermost shell, then they are stable. So how many does it need to lose to have 8 electrons? You are right about it. It needs to give away 3 electrons. So it is going to lose 3 electrons. So now when it loses 3 electrons, what will be the new electronic configuration? It will be 2,8. You can see it has got 8 electrons in the outermost shell. Therefore, let's look at the overall charge that this ion is going to have. Protons do not change. They are always found in the nucleus, so they will still remain 13. What changes are the number of electrons. Initially you had how many? 13. But you have lost how many? 3. So minus 3. So meaning you are going to remain with 10 electrons. So to find the charge, in simple terms, people, for you to find the charge, it's the number of protons, the number of protons minus the number of what? Electrons. So the number of protons is 13 minus the electron, which is 10. It will give you a positive 3. So this is the charge. So if you want to find the charge, just say the number of protons minus the number of electrons that you now have. So meaning aluminium can be written as Al, then on top I'll write a 3 positive. That 3 positive tells me how many electrons it has actually lost. It has lost 3 electrons. Very important because we are going to use it in a short while. And this is now called, it's from aluminium atom, we now call this one aluminium ion because it has now formed an ion. An ion is an electrically charged particle, like we said. All right, let's talk about now what we are calling as being anions. Like I said, anions are coming from non-metals because non-metals love to gain, and I'll show you on the periodic table later on, these ones. So an anion, I can simply say is a negatively, so I can say is a negatively, charged, a negatively charged particle. Yeah. So what makes it to be negatively charged? We can simply say an anion has more electrons. So in this case, it has got more electrons than protons. So it has more electrons than protons. So the number of electrons is actually greater than the number of protons. So when the number of electrons is greater than the number of protons, it simply means that you form up an anion. That is what you need to remember. I'll give you just a few examples so that you are able to see, but of course it is just the same. A common one is maybe oxygen, the oxygen atom. If you look at the oxygen atom, proton number 8 and mass number 16. The electronic configuration for that is 2 in the first shell and 6 there. So how many protons, electrons, and neutrons are there? So the number of protons is 8. How many electrons? It still be 8 because it's in a neutral atom. How do I get the number of neutrons? It is 16 minus 8, which will give you 8. Now remember, we said the electronic configuration in the neutral atom of oxygen is 2,6. Now in most cases, like I said, you know, non-metals, those that are forming up anions, they love to gain for them to become stable. So if you notice, in the outermost shell, it has got 6 electrons. So for it to become stable, to have 8, how many does it need? It needs 2. So meaning, what is going to happen is that it will gain 2 electrons. So when it gains 2 electrons, it will become 2, this will be 6 plus 2 will now give you 8. Let me use a red marker. So in the outermost shell, it has 8 electrons because it has gained 2. So now look at this one. The number of protons do not change. It will still remain 8. What changes are the number of electrons because they are the only ones that can move. So initially, how many electrons did you have? You had 8. Plus those you have gained the 2. So 8 plus 2 will give you 10 electrons. So remember what I said, if you want to know the overall charge, you just say the number of protons minus the number of what? Electrons. So how many protons? The number of protons is 8. How many electrons now do I have? I have 10. So it is 8 minus 10, which will give you a negative what? A negative 2 there. I hope you're able to see that. That is a negative 2. So meaning you can write now O and you write 2 minus. So you start with a number, then the charge. This is what we call as being an oxygen ion. So this is an oxygen ion. And the moment you see a 2 minus there, it simply tells you it has gained. That negative tells you it has gained. How many has it gained? 2 electrons. So the negative, it has gained. How many? 2 electrons in this case. So that is what it simply means. So this is the oxygen ion. Let me do my last example. Hopefully this is assisting you. Please, you need to master this concept because this is the language of chemistry that we use and you need this foundation. Let's look at another element which is a non-metal, fluorine, with 9 and 19 there. So if I look at the electronic configuration, it is going to be 2,7. But let's identify proton, electrons, and neutrons there. The number of protons, 9, electrons, 9. How do I find the number of neutrons? 19 minus 9, which will give you 10. So the electronic configuration, like we said, is actually a 2,7. Now, for this fluorine to become stable, remember it has got 7 electrons. How many does it need to have? 8? 1. So it will have to gain. My friend, I need 1, so it will gain 1. So when it gains 1, the new electronic configuration will become 2,8. That's the new one that you're going to have. This is for an ion of fluorine. How many protons? Or the protons will still be 9. Electrons will change. Initially I had 9, but I've gained plus 1, so plus 1, I have 10 electrons. So how do I know the overall charge that the ion will have? The number of protons minus the number of electrons. The protons, they are 9 minus electron now there, which is actually 10. So that will give you a negative 1. So meaning fluorine, you can write it like this, F minus. Yeah, it's okay, you write F minus. This is what we call as being a fluorine ion. And remember that negative tells you it has gained. How many has it gained? It has only gained 1 electron. I hope it's actually making sense for you. Otherwise, this is what you are going to be having, and this is what you need to know. Suppose I told you like nitrogen has got 3 minus. What does that mean? It simply means it has gained 3 electrons. That is important. We'll look at some few questions later on that will help you to understand these as we look at some examination questions. Thank you so much for listening.